Most traders look at one currency pair at a time, missing opportunities across related markets. In this video, I'm going to show you how to exploit price discrepancies across three currencies simultaneously using Python. We will stream real-time tick data and use Python to look for this arbitrage opportunity. In the video, I will explain how triangular arbitrage works. Sounds very fancy, very simple in concept. Give you a live demo of how we're going to use Python to look for these arbitrage opportunities. And of course, we'll give you a link to a free workshop that you can watch to build these types of strategies with Python. So what are we doing today? First, we're going to cover why Python is great for this type of algorithmic trading and why you can start in a super simple way. You don't need fancy algorithms, as you'll see. You just need Python. How we actually do it in our hedge fund for real. We'll introduce a little bit about quant science. I'll talk about my background, but we're going to actually show you how we do this for real. And we're going to talk about how Python enables this type of trade where you can't do this type of thing manually. And we're going to introduce to you a 1-hour live workshop that you can access for free. Stay tuned to the end to get the link. Quick disclaimer, this is not financial advice. Nothing in this video is financial advice or a recommendation. The content is strictly for educational purposes. Always do your own research before making any investment or trading decisions, and always consult a qualified financial professional for investment advice. Quick intro to me. I'm Jason Strimple, co-founder of Quant Science, and this series is called Building a Quant Hedge Fund in Python. We're actually running real strategies on real capital using Python, and in this episode, I'm going to show you the exact Python code we use to execute these types of strategies. First, why Python is great for trading. Well, first of all, we use Omega, which is a hedge fund in a box. This executes trades, tracks, and rebalances your portfolio. And the best part of using Python for this type of work is that it integrates with the entire Python ecosystem of tools. For example, machine learning or pure data analytics. We've been using polars recently for analyzing and processing big financial data. We're talking about 10 or so gigabytes of data, big as in running on your local machine. Obviously, you get much bigger, but this is great to use with polars. Today, I'm going to show you a live demo and talk about strategy that we're actually running. First, let's introduce what a triangular arbitrage is. This is a so-called FX arbitrage. It's called a triangular arbitrage. All we're trying to do is exploit price inconsistencies across currency pairs that share a common relationship. And the best part here is it's all basic math. So if you think about euro to USD, which is the number of euros you get for a dollar, GBP per USD, which is the number of Great British pounds that you get for a dollar, and then euro to GBP, right? So there's a relationship between all three of these currencies, and in a perfectly efficient market, you will find the euro USD is exactly equivalent to GBP USD times euro GBP. When this relationship breaks, there's an arbitrage opportunity. Now, the challenge here is that we are trading against high frequency traders. So you have to pick a currency pair that is typically illiquid, which comes with all sorts of risks in itself. We're using some of the most liquid currency pairs that you can find, so it's unlikely we're going to actually find a trade while we watch this video. You have to kind of let this thing just run all day. The other thing is that ARBs last milliseconds, so you have these opportunities that are very, very fleeting. This is absolutely impossible to do manually. You cannot do this type of trading manually. But the best part of the code I'm going to show you is this is an easy framework to extend. You can use any sort of currency pair. The key here is that we're running an event-driven system against streaming market data, okay? So this is true algorithmic trading, about as close to high frequency as we can get, and I'll talk a little bit about how we can even improve it, all right? So let's flip over to the code. So I'm gonna move my face over there, and we're just talking a little bit about the FX triangular arbitrage strategy. So we're trying to exploit price inconsistencies. We already talked about this. These are the pairs that we're going to look at when you have two different paths, right? So USD to euro, euro to GBP, and then GBP to USD. Here is the calculations. So you buy euro with a dollar, results in euro received. You sell euro for GBP, you receive GBP. You sell GBP for USD, and you're back to the original US dollar. So the idea here is that you start this process with, say, a dollar, and you end up with this process with, say, $1 or $1.0001, which is more likely. And then, of course, here is the calculation to do this in Python, and we'll see how easy this is. If this path1 variable is greater than 1, you end up with more USD than you started with, and you've made a profitable arbitrage trade. There's a second path, which is you start with US dollar, you go to GBP, GBP to Euro, Euro to USD. Same idea here, the same path, and if you end up with more than 1, you end up with more dollars than you started with, and you win. So the bid ask in this case actually matters because you are incurring the cost of the spread. And look, if none of this makes any sense to you, don't worry. We're just trying to show you how the algorithmic trading works in Python. Okay. So a quick example, you've got a pair, Euro US dollar, the bid ask, the GBP US dollar, the bid ask, and the Euro GBP, the bid ask. You do the calculations and you can see that the result is 0.9996, which is less than 1, no profit. Similar, the second path, 0.9998 and less than 1, so no profit. So in the code, let's get it going. We're going to use our quant science execution engine, which is called Omega. And as you can see, we are now set up. So this start loop thing, basically what this does is it starts the event engine in the background and lets us run an event-driven process. So we're going to create a trade size of just 200 base currency units. So that's $200. And we're looking for a minimum profit of 2 basis points. So 2 pips, tiny, right? This is the trade. It's just tiny trades over and over and over again. We're going to start the Omega app. And what happens here is I've got my trading screen open here. And sorry, I clicked the wrong button. And if you click data, you can see that I'm connected to all the data farms. And then I've also got my API connection here. So peer port 127.0.0.1. That is telling me that I'm connected to my trading account with Python, okay, through the Omega SDK. I like to call it the algorithmic trading SDK. I'm going to create 3 cash Forex contracts, okay? This is what we use to tell Python what the contract object is, okay? We're going to then start the streaming data. So app.request market data, that's all it takes to request streaming data. Done, less than 10 milliseconds. Data is streaming now into Python, okay? So here is the actual trade logic. So it looks like a lot, and you'll notice that this is a function. So I'm going to explain this in just a minute here. So first we just check if, and this is all Omega, this is the beauty of Omega, does this ticker have a bid and ask? Perfect. Yes, it does. Does this have a bid ask? Does this have a bid ask? So this protects you from situations where not all 3 currencies have a bid and an ask, basically no price data. So if any of that is true, if not, then we need to return and do nothing, okay? The first path, as we saw before, this is the start with US dollar, trade into Euro, trade Euros into GBP, trade GBP back to USD. So if this is greater than 1, we have a profit opportunity. That's the first path. Similarly, if we have the second path, so this is starting with US dollar, we go to GBP, we go to Euro, we go to US dollar. This is the second path. If this is greater than 1, we have an arbitrage opportunity. Now, the other thing to note here is that we are using the bids and the asks. So the bid is where we sell and the ask is where we buy. So this spread is the cost of this trade. Okay, so your arbitrage opportunity needs to at least be greater than the spread. And typically, the spread is going to be greater than 2 pips, but I just put it to 2 pips here to see if we can get some trades, okay? Because I might actually run this. Now, we look here to say if, so this is in basis points, okay? So if path, which is like 0.99999 minus 1, so 0.0001 times 10,000, so this is basis points, so this is a percentage value, it's a pip basically, is greater than the minimum profit. So basically, if there is greater than 2 bips 2 basis points of arbitrage profit here, then this is the profit. We immediately figure out the trade size. So we have trade size of 200 in base currency. So 200 divided by the ask, which is our euro quantity. The euro quantity times the bid in GBP. This is exactly the triangular arbitrage. So we're just structuring the triangular arbitrage. We create these calculations and then we send 3 orders. We buy the base currency, sell the euro, we sell the GBP. And the idea there is that we will get a arbitrage profit. Same with the second path. So if this isn't true, maybe this is true. Is the same exact logic here. We compute the trade sizes, but instead of the euro, we're trading the GBP. And instead of the, actually that's the rest is identical. We're just swapping out the buys and the sells, okay? So this is the execution of that triangular arbitrage, okay? Now, the best part is that we are creating an event-driven system. So what we're saying here is that we have this ticker, and on the ticker, we have an event. And the event is called update event. And that event fires every change in price. So what we're saying here, and we're adding the on tick, it's called a handler. This is the trade logic. So this function will be called anytime the tick changes for euro, GBP, or US dollar, okay? So this is the event-driven nature of Omega and how we do this with Python that you can't do manually, okay? So I'm going to basically install this event handler on each one of these tickers, and then I'm going to run it. So what you're going to see is just a simple message that says running triangular arbitrage. And in our case here, I'm just going to run this in an infinite loop, and I'm just going to sleep for 1 second. So I'm going to basically just every second, I'm going to test the market. Now, you don't have to do this every second, but you can just let it run. But it's a little bit easier to see when we do it this way, okay? So when I run it, running triangular arbitrage, and if we scroll up, we're going to start seeing some messages print, okay? And the message that prints is going to come from this command here. And every time we run this tick, we will see the message print. Okay. Here we go. So we got path 1, 0.99996, path 2, and you're seeing that the ticks are updating, right? So the changes in pricing, or the paths as we're calling them in this case, is a reflection of the updated market prices. Now what we're looking for is a scenario where this number, one of these numbers, is greater than 1. And in that case, that's where we actually will execute a trade. So you can kind of see we're a little bit far off from that, 57 and 63. So, you know, we're waiting for, 50 or so pips for these currencies to move, to enable us to capture the arbitrage. But the point is, like, this will just sit here all day. You turn this on in the morning and you just let it run, and that's exactly the way we're doing this. And it's just sitting here and looking for this arbitrage opportunity. And this is the event-driven nature of the application. It's just running and streaming data into the application and looking for this arbitrage opportunity. The cool thing is that you can do this with stock portfolios, like maybe you've got an intraday pairs trading strategy. This is perfect setup for a pairs trading strategy. All you do is just update your on-tick event so that you're looking for, say, stocks. You compute your hedge ratio and you're looking for stocks instead. And when I'm talking about the beauty of Python is that you can potentially incorporate other libraries in here. Say you want like scikit-learn, or you want some sort of machine learning library to do some fancy stuff. So it's all available to you through this process. Okay, so I'm gonna let that run and go back to a couple slides. So as a quick recap, I want to make sure that you guys are available for the free 1-hour live demo. We're going to put a link in the show notes here. So you go down to the video and check out the link. But as a recap, what we talked about was how Python can enable you to start to do algorithmic trading that you would not otherwise have access to. So obviously you can't manually look for that arbitrage like I was showing you in the code. The other great thing that I showed you is the event-driven nature of Omega, which is our execution library that we are going to cover in the live demo. You create this handler, you install the handler, and then it will just run. So every change in tick, you are getting that handler to run and fire whatever your business logic is, or your trading logic, and that trading logic will look for trades and execute those trades. So next steps, subscribe to our channel. Matt and I are pumping out video after video talking about how we are building our quantitative algorithmic trading hedge fund with Python. We've already got several videos out. Make sure you talk about this to your friends. And in the next video, we're going to cover about how we manage risk. Make sure you comment in the video. We will respond to everybody. We want to know what you want to see, and we will create a video for it. Cheers, everybody. See you next time.